Good evening, everybody. Great to see you. So many faces that I know and so many I've even heard of. So great interest tonight, not only the subjects, to see the building and also the technology we're going to be talking about and learning more about. Those of you who know me know that I, amongst many other things, chair the CIBSE FM group. Very passionate about building services, FM, and trying to make a difference where we can. And I think we've all moved building services and FM on a lot. You still hear about the performance gap, energy, quality of maintenance, problems with design, the arguments afterwards, why don't we do post-occupancy evaluation. So but I believe us and a number of us in the room have really moved things on a lot in a few years. People heard some good conversations tonight where people are saying, well, how much do you spend on the maintenance? Do you know what you're getting? Are we really approaching these buildings properly? So it's really refreshing. As you know, I've been involved with GuideM, a lot of the industry standards, and actually promoting those in best practice and in our day jobs. So it's always refreshing to get a gathering of people like tonight to discuss new ideas, innovations, and some good case studies where people are trying to make a difference and move things on. So hope you enjoy it. Hope you're getting more involved with some of our events, and I'm really pleased with Optimum and the rest of the people here tonight to actually make this event come together and the people who have attended. So thank you for that. I'll hand you back over to Mick.
Okay, I'd like to introduce you to Doug Ward from Wellcome to do the safety briefing. I think it's right, we should do that tonight.
Yeah, thank you all for attending tonight. I'm Doug Ward, Building Services Manager for Wellcome. Thanks to Geoff, thanks to the Optimum team, Schneider and Hevasure for the presentations they're putting together. I just want to go through some basic safety information for the building. There's no planned fire evacuation. So if there is an if you do hear the fire alarm, make your way to the nearest fire exits that's signed, and you'll be instructed to go to the muster area that's on there. If there's a security threat and there's a chance of an evacuation, you'll hear guidance over the PA system. Once the team have done their presentations, I'll sum up from the client's benefits perspective on the alternative maintenance techniques, what we've learned today. This is a pilot scheme that we're running, so we have some data across the last 3 months, and obviously we'll be able to sum up and answer any questions. So I'll hand back to you, Mick.
Thank you, Doug. Okay, just a few things we need to just talk about as well. Those of you who don't know, there's toilets at the back of the hall after, on the left by the coach store. At 8 o'clock, when it all finishes, we are inviting you all for a drink at the refinery. There's going to be some alcohol after, those who want to partake in a beverage, and we're going to go to the refinery. You're all welcome to join us, please do. And we have a photographer. You'll see a photographer floating around the room. If you didn't want your picture being taken, please let myself know, or Sarah, Korean, she's putting her hand back, and we can eliminate your picture from any picture we find. So please let me know. And we're also doing a video for not only for our benefit, but for the benefit of CIBSE, for their forums as well. And what Geoff has also Lisa mentioned is a certificate of attendance for any CPDs. Those of you who want them, Geoff signed them. Just please let myself or Geoff know, and we'll get your name put on it for your hours for your CPDs. I'd like to introduce a panel today. My name is Mick Brooker. I have the great pleasure of being the Technical Director for Optimum Group Services, which I've held for 6 years, and I thoroughly enjoy. Very challenging role, as you would expect, and a lot of responsibility that comes with it. To my left, I've got Racheal Oborn from Schneider Electric, who's going to be talking about build analytics. To the left of that, we've got Steve Munn from Hevasure, some great innovation work, so please go and have a look at that stand as well tonight, please. If you've not come across the product before, please do. And we've got it live, both those products are live in this building, so what you see on those screens outside is live information. And obviously Doug Ward at the end, who's representing the client, who will do his talk later on how these innovation products have meant what they've done in his building so far in the few months that we've been doing this exercise. Okay, so what I'd like to do now is introduce EMC to you. A product we've been working on for a few years. That's that the so it's at the beginning, at the end. Okay.
At Optimum, we have challenged the way in which industry maintains any building. Any Energy Maintenance Comfort, EMC, is a building maintenance standard pioneered by Optimum. The EMC standard combines intelligent software technology, condition-based techniques, and a powerful combination of innovative technologies. The EMC standard pillars, when implemented, are targeted to deliver energy efficiency savings, prolonged asset life expectancy, comfort improvements. EMC techniques will continuously measure energy usage within your building and be challenged to make the assets run efficiently, demonstrating energy savings. EMC has developed a maintenance process that is used to systematically and scientifically determine what maintenance process should be carried out to ensure that physical assets continue to perform as they were designed and as their users want them to do, in a cost-effective and efficient manner. EMC techniques have proved to reduce help desk calls and engineer reactive expenditure in the long term by ensuring that the plant issues are proactively highlighted and rectified proactively, allowing the engineers to attend these problems before the reactive calls are placed by the stakeholders. By analysing the data being downloaded from the building management system and associated analytic tools, it is possible to focus the engineering teams on plant that is operating the least effectively, both making the most effective use of the labour available and leading to cost savings by the client. Unlike in planned, scheduled maintenance, where maintenance is performed based on predefined scheduled intervals with a set of guidelines, EMC maintenance is performed less frequently or only after a decrease in the condition of the equipment has been observed. Compared with planned, preventative maintenance, this increases the time between maintenance repairs that will then free up the engineering teams on site to respond to reactive calls. Additional to the real-time data capture, other industry-leading systems would be utilised to assist with the monitoring of the plant and equipment, such as vibration monitoring, thermography, air-water monitoring techniques, as well as state-of-the-art EMC Plus techniques. In summary, EMC will require investment in training and technology for your engineering teams to drive results. Those initial investments have already delivered tangible efficiency savings and returns for our clients.
Okay, that's the short video of the EMC. You're going to see a lot of those slides replicated now in my presentation. The first thing I need to say is, why have we decided to produce a standard that's outside SFG standards? Why didn't we just chug away at those list of points that we've been all used to? As you check, a great standard we all follow and love. There's nothing wrong with it. I believe from what we've been listening to from our clients at the coalface, and I don't have a desk, so I spend all my time out at the clients, speaking to them, and I hear three common themes continuously in all the years that we're doing. Now that could be at a monthly meeting, it could be at a tender proposal presentation. I hear three things: energy, labour resource, and the best use of the labour resource set out for you, and reactive calls. Those are the common things that we've been hearing for the last 6 years that I've been doing this job at the senior management team for Optimum. What have we done with that information? Yes, we could carry on doing SFG 20, but that's not what we want to do. We want to bring a new product by bringing all these great innovative ideas that we see out in the field, that you're going to see tonight, and put them into a package that we can put a tangible product that can make the best use of your building and the labour resource that you have in that particular building. AMC versus SFG 20. SFG 20 on the left, you labour load your building like we all do at tender stage, and you'll see your man hours, and your cafe system will print off your ticket. The engineer will go off and do his maintenance, but is he actually doing that maintenance? Is he actually testing how that machine's going to be designed, that asset? Is he checking a flow rate? When was the last time a flow rate was checked in your buildings when it was commissioned? You probably won't go back to that asset and do that particular exercise for years after. Okay? EMC does that for you. You're relying on data capture by the individuals doing that other task. All the reporting is a manual, and you have increased downtime of plant when it's not operating. What EMC on the right does is real-time data capture. Its use of the latest technologies, it reports functionally, it reduces the downtime, and it produces savings. We talked about the three pillars in the video. Pillar 1, energy. Pillar 2, maintenance, to carry the best resources available at the point of work. And 3, Pillar 3 is your reactive cools. To start this process off, what you need to do is to find out all your energy performance in your building. What is your building actually doing now, today? So you make up how it's performed from an electrical point of view, a gas point of view, and water usage point of view, and you track those changes. EMC will then be implemented to challenge those energy and drive the energy to get it lower. And we use the engineering teams. We're not getting external consultants or charging you more money to do anything like that. This is being done at the point of the coalface with the guys, and that's what we've done here. We've done some internal training with the teams to use these technologies. We're not paying extras. They're being done by the boys on site. Okay, and they've been trained by our internal training program to do that. Pillar 2, maintenance. What we've done, we've looked at the SFG car sheets. We labour loaded this building to SFG standards, and then we loaded it to the new EMC standards, and we saved a lot of money, about £46,000 by doing it the EMC standard. Pillar 3, comfort. We take the historic data of all your call-outs, all your reactive calls, the hots, the colds, the mechanical issues, the air handling issues, the pump issues, and we capture all that data for the last year before we implement EMC. We want to see it track. We want to see that lower. And remember, we're doing building analytics to that as well. EMC technologies. In the red Optimum logo here, you'll see the standard EMC technology that we use. Building analytics. Obviously, Schneider have build analytics in their products, but there are also other platforms that you can use, Demand Logic being another, and other companies out there as well. Vibration analysis, thermography, noise analysis, water flow management and airflow management. Not a tool that your standard engineer would use on a day-to-day basis. Would you agree? Okay, you'd normally have to call consultancy services in to do that task. What we've done in EMC, we've invested with that plant, with the client. We've trained the guys on site how to use those products. The Contonic AC 6-mile water flow meter point of view, for example, will give you an exact flow rate. Okay? We've taken the engineer, we've sat down into a classroom, just myself and him, and we've talked about the standard formula that we all love. Q is equal to MC delta T. Very simple. Okay? Specific capacity water is the standard. For pure water, we know that standard figure. We know the temperature difference your plant might be doing, and we know the flow rate. With that, you can look at what your kilowatt duty of that plant is doing. Is it working to design? You get your technical submittals out, and you challenge it. Not a normal activity that you would do on an SFG 30 task. And on the right here, we have the EMC Plus technologies. I can honestly say, at the Wellcome, they've invested into 60% of those items on that right-hand list. And they are available there. We've got our table. You can talk about any of those items if you're interested in any of those later. See Neil Wilson, our energy manager, who will also talk about those. EMC techniques again, standard package. Here you'll see Peter Dunham, technical manager for the Wellcome here, our employee. He's here tonight, looking at the building analytics platform that's live in this building now. And all the other technologies to the right that we all know have been bonded together as one package to reduce energy and reduce reactive calls that we are now finding in this building. It is very simple, gentlemen and ladies, very simple. Okay, EMC three pillars, investment versus payback. We approached the Wellcome with this product back at the back end of last summer, around about September, October last year. In fact, it was probably in the middle of the summer. I sat down with Alan Aldridge at the time, myself and John Crean, and we introduced this product to him as a pilot scheme. To, can we use it in your building? Can we suspend SFG 20 and start EMC? And this is a great client. Like they all sit in a great client. See, he embraced it. They've now installed it into this building. But what we did, we looked at all the historical data, predicted energy savings, predicted labour savings, and predicted reactive calls based on the historic data. And with that, On the right-hand bubble, we saved them £62,000 a year, based on a 5-year period, was £312,000. At the bottom, you've got the technology and training, was 258 as an investment that the client had to make. And we've made that here. And with a summary, you can get about £55,000 back over 5 years. May not seem a lot of money, but that's what we predicted. We had no historical data to work with at this point. We've been doing this now from last year, back at the last year, through to this year. And what you'll see at the top and bottom, 2 separate graphs, one for gas and one for electricity. If you take the bottom one, for example, Wellcome Trust 2005, building 215, electricity consumption. We've got the yellow is 2015, electrically input power, kilowatt hours. The blue is 2016, all historical data. Since we've introduced EMC, January and February, look where the red line is. We've made it a priority. We've challenged it. We challenged how the plant's running. We've optimised the plant. We're not having chillers running in and out. We looked at the building load and we've set the building load up, the plant up to run to the building load. Very simple, not difficult. And the gas at the top, now that's starting to come down as well. So we looked at boilers and we worked out we can run the building, look at the load profile, we can run the building with one small boiler instead of one big boiler. That means you're running one smaller primary pump and the savings are there. Reactive tracker. We've got the blue and the purple, the pre-EMC and the post-EMC. From January 2016, you'll see the trend is pretty standard for winter conditions. You get a lot of reactive calls up here, and then as the spring comes, they tail off, and then when the summer kicks in, they normally go up again, and then in the autumn, they tail off. But since we've been doing EMC, we really targeted the plant in areas. And as predicted, we said the reactive calls will go up, and then we expect them to go down once the plant starts working efficiently. As you can see, from January and February of 2017, we only had 16 and 15 reactive calls to date, as opposed to January 15, 16, 60 and 58 reactive calls. Now bearing in mind, it was quite a cold January in this country this year. A lot of -6s, -4s, it was quite cold. And those are the results we are getting. Okay, I'd like to share this slide with you. This is a demand logic white paper from CIBSI, one of our other partners who we work with. And I do like this slide because it looks a bit muddled, it looks a bit complicated, but let me just explain what it does. This is all the fan call units in a building. Each one of these bubbles here represents a fan call unit. Okay? And the areas here is where all the fan calls are working efficiently and well. The rogue ones who aren't working well are up here, all outside the zone. Why go and target these on the maintenance? They're working okay. Yes, clean the filter, but they're working fine. You can see they're working fine through your analytics platform. Let's challenge these ones. And we can see them on the platform they're not working well before we get that reactive call. Let's not wait till we get a reactive call. Let's deal with it. Okay? And that can be the same for those of you who may work in data centers. Each one of these can represent a closed control unit as well, remember. It's basically an air handling unit. Okay? That, ladies and gentlemen, concludes my part of the slide. It's only 10 minutes I've had. I think I've had more than that, so please forgive me. And I did tell Stephen and Racheal, don't go past your time. So what I'd like to do now is hand over to Racheal Oborn from Schneider while I go and get a drink of water.
Good evening. My name is Racheal Oborn. I'm from Schneider Electric, and for a Thursday evening, this is a great turnout. And I'm really thanked for Optimum and the Wellcome for letting us actually stand here and actually talk about a subject that certainly I'm passionate about. and I know Schneider are as well. So I'm going to talk to you about 10 minutes regarding analytics for buildings. It's a very touchy subject in terms of how we want to use data, and analytics is the drive behind this. We see this now in planes and cars, and it's in our TV set, it's in our deep fat fryer and our oven. We're getting data from here. When I was asked to talk about this subject, my question was, why? And it's not a case of about standing here in front of great people. It's actually talk about what do we want from this? You know, why analytics for buildings, and why analytics for anything at all for it? So, can we crunch data and can we get more from it? Of course we can. And I looked carefully what we really wanted to achieve. Energy savings, I think, is key. Building efficiency, carbon footprint, carbon efficiency, and that side for it. But they're all outputs. They're outputs for a process for it. And what this is really about, analytics, is about data, big data. Now, this whole building's full of data for it, but how do we actually make use of that? How do we actually crunch it into some form of actual information for it and some form of intelligence? And I think this is where this whole issue around analytic packages, whether it's a Schneider product or a demand logic product or anyone's product, we're all trying to get data and trying to make it useful. And I think that's really key behind that side. So I can see, I'll put this slide up because I think it's very useful, and it's trying to look at this big sky thinking, this blue sky thinking we want to look at. And IoT may play a big part of this, because we are going to get every device, every pump, every valve at some point is going to be wanting to talk to itself, talk to all the bits and pieces in the kit in the building for it. But actually, how do we get information from those connected devices, those IoT devices, into a platform that actually makes some sense for us? And we certainly see energy use, automation, and software will converge together as one for it. But for that to happen, there has to be key drivers. Now, that might be obviously the things we're going to talk about here this evening for it. It'll mean investment from clients like Wellcome. In a sense, that is something which we know we want to do, and it's something which is really key for the future of building performance and certainly reducing energy. So we look at different drivers behind for this, and sustainability is all about push for green. So obviously we want to focus on environmentally friendly solutions for it. It's no good having sustainable policy if we don't try and focus on those green issues behind that. We look at performance, drive for high performance buildings, high performance products for it. And that should be part of a process in terms of buying, you know, what do we look to buy the best products that are most environmentally friendly. Sometimes it works, sometimes it doesn't. A Prius car costs money for it, costs X money than a normal car for it. That's a choice we make. In terms of comfort, we want our buildings to be comfortable, both in the workplace and both at home. And we do focus on building performance, and we measure that building performance by how much energy it uses or how much carbon emissions it puts out. But what about well-being? You know, we never seem to talk about the well-being of an employee in the building as an output. A happy employee certainly is a very productive employee. And cost, aging facilities, old equipment is certainly going to drive costs through in the future, and we have to be really wary of that as well. So risk management, as we get more connected devices into buildings, then there's going to be a big increase in security. And as we tie down systems, then we are going to have competing forces, because at the same time we also want to open up these systems to all the devices to connect them all together for it. So that's a challenge we're actually going to try and have to overcome. But as we go into more IoT space for it, then we're going to have a fan call talking to the cloud. Is that acceptable? And it's something we have to consider for it, because it's about the data and crunching this data into something that we can physically use and make an action from that. And new technologies, every day we see something new come to market. It's another connected device for it, but it's also another data output. So again, we have to think about this whenever we do this analytic models. What's it going to look like in 3, 4, 5 years' time? So we have to draw, put like a small line at the moment and try and look exactly what do we have at the moment. So most buildings, this building's the same. Maybe buildings across the road the same for it. We'll have a standard BMS system in here for it, and it's semi-connected, semi-intelligent for it. But a building automation system will come in many guises. You'll have a BAS, a building automation system, you'll have a BMS system, you'll have a BEMS, and there's someone going to put an I in front of BMS for it and call it an intelligent building management system. Well, what makes it intelligent? You know, if I'm a valve, I have an instruction to turn on and turn off it. Does that make me intelligent? No. But if I'm a valve and I want to go and talk to other valves, you know, my friend, the valve chiller, and my friend, the valve pump, but I also want to talk to other bits of equipment and consider the weather, then I'm intelligent. So I think it's this whole shift towards an intelligent building management solution is certainly what's obviously going to drive this whole analytics piece that we look through. And again, a typical graphic of what we would see from the BMS system, central controllers feeding data back to central server for it, and then we may then connect HVAC, lighting, energy management together for it. So as we start bolting these systems together for it, then we do come into this risk space in terms of security. We have to consider that for it, but all these devices and those systems are all talking to each other or wanting to talk to each other. So how are all these going to come together? And again, if we're looking for data richness, we've got to open up these systems for it. And certainly, not too long ago, the offer from people like Schneider was a closed protocol system for it. Nowadays, obviously, the drive, the selling point, is to have an open protocol system that allows everyone to talk to each other. So it's just something that obviously we have to just bear in mind for it. So we'll take it a little stage further, and how can we now look at putting analytics into a platform? We look at data. Where we want to go is data to impact instantaneously. No human manpower, no human input, or nothing, just something that happens as a matter of fact. You turn the light switch on, the light bulb comes on. You don't have to go and start turning the light switch and make it work a bit better for you. It's an instantaneous event, the same way picture or video is on demand. It's here for it. But certainly we look at data and the enrichment of data for it is really key to actually try and get the best from any analytic solution for it, and not just get a whole bunch of data that really we might know or might not know about. So data is just data, and if we look at if it's added with context, then it becomes knowledge, and certainly with insight we can make action, and action can make an impact. So if you think about what needs to happen just to get an impact from here for it, and that's certainly a huge equation for it in terms of interventions from people and intervention from systems, just to be able to actually make a decision or an impact behind the So we look at analytics for buildings for it, build analytics, a demand logic platform, there's other platforms in the marketplace for it. It's the same system to actually try and get data, grab it, and actually make it actually make sense for it. There's two types of products on the market. So we have a software as a service, a SaaS service for it. So that'll be, you'll buy your software, you'll make the decisions, you'll write the rules behind that for it, and you make those actions. That'll be your choice of how the building goes through. The other option is an MSaaS service. So this is a managed software as a service. So this is where we'll have software coupled with expert services. So that'll be industry professionals, engineers who know the buildings, people actually know the product, know the analytic platform for it, and those coupled together turn into Superforce, a collaborative Superforce of technology and data together for it. That's a really, really powerful product. And certainly M-Class is what's here. in the Wellcome building for it. And it is a key differentiator, we feel, in how people would view an analytic product for the future. So then we move to the people factor. So at this stage, we've got a BMS system, we're going to put an analytic package in there, so we're now intelligent, we're getting lots of data from. So people in this room now may be thinking, well, why do we need people? Do they add any value? You know, that's a really serious question for it. Within our space, we talk to engineers, we also talk to customers. And so our biggest feedback from customers are, well, your engineer, he just comes to site, he performs dark arts and voodoo magic. We don't know what he does. And he gets an invoice at the end of the week and think, that's great. But, and then we have the other engineer who'll say, well, the client doesn't really see value in me. I'm not sure. Maybe I feel I'm not wanted anymore. I don't feel valued for it. And that's a perception issue for it. And that's a dangerous place to be. So we have engineers in any field, whether it's BMS, whether it's pumps and waters and heat and lighting for it, in the same space for it. They're doing work, and it's trying all the time to try and provide that value from it. And obviously, if we look at any engineer, they are a viable asset. And this is an opportunity to actually upskill themselves. And to quote a passage from Jim Rohn, your life does not get better by chance, it gets better by change. So we want engineers to see this value behind for this. And this shift to smart operations, it's here, it's taking place even at this building here. This is part of this whole EMC shift for it. And when we move from reactive and preventative to preventive and predictive, I mean, that's small word changes, but that's huge. If we can predict and prevent something happening before it's happened, that's an impact for everyone. The customer, the employee, the building, for everyone involved for it. We then have obviously a shift then from on-site labour. That might be a BMS engineer who's spends his time here doing maintenance and checking things which are really working fine. And Mick touched on it before. Why check things which are working fine? It's just a waste of energy, it's a waste of money, it's a waste of time and resources. But then obviously a client will say, well, the guy's just sat at the head end, he's just doing stuff. You know, and sometimes it's called stuff, you know, voodoo magic, dark arts. That's what people see as a BMS engineer. So on-site only now is moving to remote and on-site. So we're taking advantage of connected services into our bureau or into other bureau services. So having the ability to actually have remote support actually helping our building performance certainly will be helpful for the future going forward for it. And for those labour-driven projects or labour-driven contracts where you'll have a BMS engineer who'll spend time running trend logs, then let the software do the grunt work, the heavy loading work for it. And what we end up with in terms of that process then is a super force, a super everything for it, where technology and data come together with labour, and that's the model we would certainly see happening as we maybe move and engage analytics in terms of moving forward. So what can analytics find? Certainly, this is certainly not an exhaustive list, but let the software go and do that work. Let the software find these faults for it. And the key here is it looks at individual systems, but also data sets, data group sets for it. We're already seeing analytics being now grouped with, I don't know whether you know the Cassandra effect, where we're now bringing third-party data sets together. So how you lift performance, occupancy of a room for it. Now put that together with data, building data for it, you have a really, really powerful product, which is actually going to get put through and make our buildings more efficient. So to summarise on the analytics piece, before we talk a bit about Wellcome 215, what can analytics drive? Obviously, we see energy savings coming out of analytics, because this is the global product from Schneider. We see around about 9% each year of avoidable energy saving costs. That's a huge number. whether you, no matter how you square it for it, 9% of something, fine, but in terms of the engine numbers we see, even what Mick's talking about here, this building for it, that's the size of number for it. Operational efficiency, so as we manage the assets better, and as we maintain that maintenance schedule and get that correct as it should be, then that equipment obviously will last longer, and obviously won't fail as quick. And then we have a system for soft landings. So a building going through a construction phase or even to hit PC, it's a lot of work. Build analytics or an analytics package installed at that production stage has the ability to actually find obviously these snagging faults and actually help and speed up the whole PC process. If we can make smarter decisions, then we grow our ROI. So I'm just going to talk a couple of slides, so I know my time is slowly running out. We'll talk about analytics, or build analytics for Wellcome 215. We're starting this building here now, and we have, as Mick said, we have now live feed from analytics working this building for it. But why did Wellcome, why did Optimum to consider this solution for it? And it's all about trying to be different, change away from the norm, but at the same time, be cautious. Make sure we can back up what we're talking about for it. So it was a cautious approach to considering skills challenges and resourcing issues for it. Even we, Schneider, the global company for it, we have resourcing issues. Skills of engineers are actually changing for it. So if we can get technology to actually do some grunt work, that's a great thing to do. Obviously financial and energy issues for it, they're always key points. But I think one key issue here, which I feel personally is important, is employee well-being. We don't measure it. And certainly, if someone who feels hot and cold for it are going to complain, they're going to raise a ticket into a help desk for it, they're not going to do any work for maybe 3, 4, 5 hours. Now that, in a sense, is a travesty for the building owner and for the employee themselves for it. People then obviously will maybe fall away, maybe leave for it. So in terms of this project, in terms of building 215, we're monitoring 557 pieces of equipment across one BMS system. The project installation time with this project, which is run in conjunction with a validation project, was 62 days. It was a flawless installation for it. We spent 10 days on site doing data gathering, and actually helped Optimum and the Optimum team in actually finding assets that didn't have the full data. Now we actually have a full data catalogue of every piece of equipment and what it does, what its ratings are, its flow rates are. So that's a good process actually being done together. The other work was done off-site. So it's a really simple process to install an analytics package if you know what you're looking to get from it. And to summarise some results, where we're at the moment, we're at day 38. So that's certainly it's a nice little window of opportunity to measure information from for it. At the moment we're monitoring 4,200 points. Now we do that monitoring every 5 minutes. So while I've been standing here now, we've actually sent out 8,400 lines of data into the cloud. Since we've been monitoring 215, we generated 42 million lines of data. That's huge. Imagine an engineer trying to do trend analysis and trend logs and fault diagnostics on that much data for it. You physically couldn't do it. You need an army of engineers to do it. We found over 590 individual faults on the building since it went live on 28th February. And to date, so far, we've identified £30,000 of avoidable energy costs. It's an instant ROI. At the same time, we found 370 well-being opportunities for it. So these are comfort faults. So this is an opportunity where we may have a fan code maybe not working correctly. And as Mick says, if we're looking to check a fan code, chuck a £20 spare cent into the fan code unit and let the analytics software check it for you. You don't need to go and do this temperature and checks 1 to 2, 3 times a year for it. Let the software do the work for you and actually focus on exactly what's wrong and what's fault for it. At the same time, we found 220 maintenance opportunities. So to close out, I want to share with you a short video, 2 minutes, of a customer case study with Boston Scientific. The things obviously Greg talks about, I think obviously we've talked about, absolutely talked about, and we'll be talking about this evening for it, and it's certainly an interesting video to watch and understand some of the comments that Greg thinks obviously regarding analytics for buildings. Okay, thank you, and hope you enjoy. Hope it works a bit.
I like to make things work better. I like puzzles. That's the way I look at everything I do here. It's all trying to figure out how things work and make them operate a little bit better. My name is Greg Lamson. I'm a senior facilities engineer with Boston Scientific. We're in Marlborough, Massachusetts, the global headquarters. 5 buildings on the campus with a total of 645,000 square foot. My professional priority is to make the facility run as efficiently as possible. The hardest challenge is trying to keep everybody happy. The majority of the campus is office space. We do have some labs, mechanical spaces. We have a 9,000 square foot daycare. We monitor well into the thousands of data points. Without a system to kind of funnel down the critical points, it certainly can be overwhelming. Building analytics, it's like an engineer, and it's just continuously running 24/7.
My name is Nicolette Fondel. I'm the Service Account Manager for Schneider Electric, representing Boston Scientific. The building analytics really help them maximize and utilize their BMS and really understand the functionality of the BMS. Facilities typically only use 20% of your building management system. So this gave Boston Scientific the ability to really fully maximize the system and understand how it can best serve them.
I review building analytics just to see how we performed the previous day, if there's any new issues. It allows us to be more efficient. Instead of having a handful of guys run around just trying to figure something out, we can kind of point them in the right direction.
When we first installed the building analytics, it paid for itself instantly just by the initial measures that we took. Not only does Boston Scientific see the energy savings from what we're doing, but we submit a report to their utility itemizing all the actions that we've taken in the building analytics tool.
Building analytics, it makes me look pretty good. I mean, we've been making a lot of improvements. When I get the quarterly report, and it shows that I've continuously reduced energy, that's more that you can invest, and then you have fewer complaints because people are happy. The happier they are, the more work they're doing. That's a good thing.
Thank you very much.
Thank you, Racheal. Okay, guys, I'd like to invite Steve Munn from Hevasure to the platform to introduce the Hevasure product.
Okay, thank you, Mick. Thank you to Optimum, and thank you to SIPSI. My talk is slightly technical, but I hope you don't mind. I'm sure you're a very technical audience. It's about how we actually prevent corrosion damage in closed heating, ventilation, air conditioning systems, water-based systems these are. So the topics I'm going to cover are the manifestations of the corrosion damage, what the causes are, the importance of good practice in design, commissioning and maintenance, the limitations, this is quite important, the limitations of what's actually happening at the moment. And we've investigated hundreds of failures, literally about 200 failures, where companies have relied on water analysis and it hasn't shown up the problems. And then we finally move on to remote and continual monitoring as a way to actually stop all the damage occurring. So let's look at the manifestations. I'm sure you've all seen some of these. Leaks in pipework and radiators, failures, boilers and chillers, damage to control valves, letting by where the control valves aren't doing their job, poor flow, blockages in pipework, radiators and the like, losses of efficiency, Now, the point about this is the first two are usually really obvious. Everybody can spot a leak. You can tell when boilers and chillers aren't working correctly, but a lot of the things are actually hidden. So many buildings we see, they are suffering from poor flow, blockages of pipework and things, loss of efficiency. The thing about corrosion in pipework, it's really hidden, and often until it's too late. And so what we're doing as a company is looking at how we can actively check on the conditions of these systems to actually tell us whether these problems are occurring remotely. Okay. So, looking at leaks in pipework, this is an example. This is a sister company of ours, Midland Corrosion Services, you may have heard of. We got a phone call. I remember I took this phone call about 4 years ago, and it was a very casual phone call. Oh, we've got a leak. Can you help us on this one? And you can see the picture of the leak there in the top right-hand picture. About 3 years later, that resulted in legal action, more than £10 million of out-of-court settlement. All right? So the guy who's responsible for that didn't realise they got a problem until it was too late, and all the parties involved had to settle out of court, whether they were innocent or not, and picked up a share of that bill. Here's some other damages. So it's not just the steel. You see damages to control valves, glass excessive flow rates and oxygenation, damage to copper, and also damage to stainless steel. So it's not just carbon steel, it's a lot of other components are getting damaged. We talk about loss of efficiency, and these are two examples again which we looked at. The picture on the bottom left-hand corner is due to gross aeration, and we see a thin-walled carbon steel pipe where obviously the flows will be severely impeded by that corrosion. And the top right-hand picture shows a picture of all the corrosion debris within an aluminium heat exchanger. And again, the heat transferred would be substantially reduced, or will be talking about this. So what are the causes? What is causing all these problems? Let's look at the environmental factors. Number one, aeration. Dissolved oxygen in water, that is the primary driver of corrosion. Exclude air and you're going to stop most of the corrosion from occurring. We do see some effective water composition, and that can affect the other materials such as stainless steels and aluminium things, so pH, ammonia, sulfates, chlorides. Temperature. The need for proper cleaning according to Hevasure to remove deposits and flux residues, that's also important. Flow rates and stagnation. Obviously you don't want excessive flow rates, and that causes erosion corrosion. Equally you don't want stagnation, because that causes microbial issues. MIC, microbial influence corrosion. Bimetallic couples, you should never couple certain materials together, copper and aluminium, and also water treatment is important as well, the choice of the right inhibitor. Just quickly looking at oxygen-induced corrosion. There's only several ways oxygen can enter a system, either excessive pressures during the heating and cooling cycle, and that leads to leaks of the PRBs and the need for fresh makeup water. Negative pressures occur into the system. Leaks also cause the need for fresh makeup water, and also some cases we come across where people are using non-barrier plastic pipework. Moving on to the importance of good stock practice, and let's look at the first statement I need to make here. As a consultancy company, we always made a point of saying to people, if you've got multiple problems in your system, it is very unlikely to be the component themselves. It is a systemic problem. It is not, we get failed valves, we get failed components landing on our desks. When we do a site visit, it is hardly ever the component itself, it is a system-wide problem. Due to the water composition, due to lack of engineering integrity of that system. Poor design, poor commissioning, pre-commission cleaning, or poor maintenance. Or sometimes the incorrect choice of chemical inhibitors. So let's just look at these in turn. The importance of good design and construction. CIBSE Guide B1 heating 2016 and B3 for air conditioning should be followed. The correct selection of materials. So what you'll see, the theme of my talk is it really is a holistic approach needed, a complete thinking, not just having a mindset around one aspect. You need to think about all these aspects. Selection of materials, flow rates, installation of sufficient expansion capacity, installation of sufficient drain points, automatic air valves, and also thermal insulation. Good commissioning. Let's look at good commissioning. For the pre-commission cleaning, B3 BG29 is recommended. And again, it's not essential. People are saying it's an absolute Bible and you have to follow that. It isn't essential, but there's some good things about that. Certainly systems should be clean anyway. Systems should be flushed when they're first installed to remove debris and swarf and other type of components. Sometimes chemical cleaning is needed. Again, we would sort of say this is not mandatory and take care when you do this. Water treatment, use of biocides to get rid of microbes and corrosion inhibitors. Now, the second point about corrosion inhibitors, in the UK there's a very strong reliance on chemicals. If you go to Germany or Europe, less so. I think as an industry we need to ask ourselves whether or not this is the right way. Certainly inhibitors have their place, but as a secondary line of defence. Inhibitors shouldn't be seen as the main line of defence against a poor engineered system. Keep the systems airtight, keep them properly pressurised. If you want to use inhibitors, choose the right one, keep it at the right level, and keep it topped up. And also about commissioning, obviously setting up the valves is important to get the correct flow rates. We do not want to get stagnant water anywhere in that system. The water must be flowing, not too high, not too low. Right, which brings me on to the limitations of water analysis. Now, there's a lot of companies in the UK who would go down the line of, to maintain the system, you send an operator on site, you take a water sample, you do chemical analysis of that water sample, and you are judging the health or otherwise of a system based on that water analysis. However, it is not sufficient. It is not the best way to maintain the system in our view. It's not always sufficient to detect corrosion in systems. We have come across many failures where people have followed the BISBE guides to the letter. They say that the water samples are good, there's no problem. Why are we getting failures? Because they were not attending to the other points. And also, it's only a snapshot every 3 months. So or 2 months or whatever you're doing. So you're going to miss anything that goes wrong in the system in the intermediate time. It cannot give the cause of the high metals or dissolved solids. They'll tell you you've got high metals, high dissolved metals. It won't tell you what's causing it. And it's open to misinterpreting. Low iron readings does not necessarily mean you've got no corrosion, because the Fe2 plus and Fe2 plus is very soluble, Fe3 plus isn't. So you get the magnetite, hematite ratios, and we've seen systems full of magnetite, which is insoluble. It does not come out in the water analysis. So water analysis is open to misinterpretation. And I like to make it akin to you as a person. If you went to a doctor and you said to a doctor, tell me I'm healthy, I'll give you a urine sample every 2 or 3 months. The doctor would say to you, I can't tell you you're healthy, it's only a snapshot of 2 or 3 months. I need to measure your blood pressure, your heart rate, your cholesterol level, etc., etc. And I need to measure every 15 minutes. Why do we think that these expensive assets can be treated like that? We need to be getting remote, continuous data from these assets, not just water sampling. Which leads me on to continual remote monitoring of systems. So what would the basic requirements of a monitoring system are? And we looked at this when we started about 5 years ago, and we do measurements of all these buildings to see what's going on. We thought, rather than wait to get called in when there's all these problems, surely we must be able to capture this information. So when I joined Midland Corrosion Services before Hevasure, we looked at what we needed from a remote monitoring system. We need a way to detect conditions which give rise to the corrosion before the damage occurs. There's no point in saying that the damage has occurred. We need to know what the conditions are before it occurs. And if things go wrong, we need to know why it's happened. Not just it's gone wrong, but if there's area of the system, oh, it's caused by a pressure problem or it's caused by a leak. We need to be able to view that data remotely from anywhere. We wanted to set up a fully integrated plug-and-play system. Engineers, you guys are too busy to have to wire in data acquisition systems, sensors, power supplies and stuff like that. You want a system that can easily be installed. So a system is only as good as the sensors we put in. So we have 3 different groups of sensors. First and foremost, we're looking at system integrity. We look at water makeup, have we got leaks in the system? We look at pressure, is it at the top of the system, is it properly pressurised? We look at dissolved oxygen, is it airtight? We then look at the water condition. We look at conductivity, and then we convert that into a measure of the inhibitor levels. So we characterise that water and we look at various aspects, and we can do this. We measure the pH, we can also get biofilm. We then also look at corrosion in that system, and we've developed cheap ways, low-cost ways to measure corrosion, not only on open surfaces, but also within crevices. And crevices are normally the onset of corrosion, and we want to pick that up before damage occurs. So this is the Hevasure system, and we have a dashboard which we set up the tolerances, so it's green if it's healthy, and it's amber if it's going outside tolerance, and it turns red if there's something critical. And we will get an on-site engineer to attend to that particular issue. You can drill down into the data, and you can look at the trends over time, so we can tell what's happening. And we've got information here, and this is installed in the Wellcome. So we have got this system now, it's been going for how long, Mick? 2 months? 3 months? We have got data now for the past 3 months, and I'm working with the guys, and if we do see something going slightly outside, we did have a bit of a leak recently, and we were able just to sort of say, well, okay, this is an issue, and we were able to attend to it. No damages occurring at all. We're picking up on all these, and this is a very healthy system now. This is a picture of our monitoring station, and if you do get a chance to go upstairs, this is a picture of our monitoring station in the Wellcome, and you can see there we have the sensors in the manifold below. Above that is a data acquisition system which captures all that data, stores it locally, sends that data up to the cloud. We then capture it remotely. And over there you will see on our stand we've got our next generation, which comes with a display as well. So in summary, there are many types of corrosion damage which can occur. Some are obvious, but some are not. Some are really hidden. They can come about because there's sometimes problems in design, installation, commissioning and maintenance. But the main driver for corrosion is dissolved oxygen. So systems should be kept airtight. Engineering integrity is very important to minimise air and water ingress. The pre-commission cleaning should ensure that systems are clean and free from microbial contamination going to Hevasure. Continuous remote monitoring of the key parameters is necessary to flag up the problems before any damage occurs, so that remedial action can be taken. I think that's the end of my talk. Thank you.
Okay, the moment I've been dreading. We're going to get Doug Ward from Wellcome to give his overview of how EMC and these other products have worked in his building. I've not seen what he's going to say, so Doug.
Yeah, as I said earlier, it is a new pilot scheme, and we're just gathering data since January, February time. So for some of these schemes, some of the benefits I've noticed as a client so far. I work closely with my colleague Corbett on the energy and environmental performance of the building. So our social and reputational benefit is enhanced. We've reduced energy wastage. We're just about to purchase our carbon allowances for CRC at the moment, and that looks like it's on a downward trend, so positive there. We work closely with Camden Council and the Camden Climate Change Alliance to try and enhance the environment around our building. Another benefit is obviously enhanced life cycle on the plant. We expect the plant to be running at optimum performance now as we look in every day. Now, one of the things I do, travelling in on my early train, is Alan in? I quite often log on to building analytics now and see the affordable costs that are showing on the building analytics system, which is Schneider system. It's amazing what you see, and in no time at all the Optimum team have got together and they look at that every day with us. Culture change, they look at what plants running that shouldn't be running, what sensors are out of calibration, what flow rates are out of the parameters that we expect. We've worked across the previous 6 months before Hevasure product was installed to make sure the water quality of the building is as good as it could be. We've now got the Hevasure product in place so we can monitor the corrosion levels at any time, pressure drops. At that point, we're now moving towards adding a product called Endotherm, which is being managed by Neil Wilson of Optimum. In January 2017, we recorded the lowest grid electricity consumption in the 10 years, or 12 years should I say, since the building's been open. So we feel it's an amazing achievement. And when you look at the figures that Mick Brooker put in his presentation earlier on, them figures on gas and electricity consumption are verified by myself and Corbett on a monthly basis. So that is not something that Optimum put in that's not been proven. That's validated by us in the middle of each month. Gas and water efficiencies, the consumption also is reducing on both of them. And we're looking and reviewing against the expected and the original design of the operation. We're constantly reviewing the engineering design and the controls and the metering in the building, looking to strategically locate further meters in the building so we can make even more efficiencies. And obviously moving on to the next steps, we've got plenty of data to analyse, we're aware of that. The whole team need to be engaged, the engineers and the engineering team and the fabric team that Optimum recruit here are well aware of the system. And this is run right through Optimum, through Mick Brooker, Stuart Mears, who's played a key role in running the programme, and right down to every member of staff. I've a few thank yous to say to sum up, and then I'll take questions and answers, as I'm sure Mick, Racheal and Steve will. Thank you first of all to Wellcome for providing a great role for us to support this project. One of our guiding principles is to act boldly, and we've acted boldly on this, and I hope there's more that will follow. The Optimum team, in particular, like I say, Mick, Brooker, Stuart Mears, the team on site, Peter Dunham's done an excellent job. And I know the engineers in the team have all supported that. Colbert for verifying the data. Ted and Alan from Wellcome for supporting the budgets when we go there asking. Ted even encouraging us today to come back with more ideas. Schneider technical support team. Hevasure, obviously, Sibsy for providing the event. And we work with a consultant, Mike Freed, quite closely on other projects for FPC. So a thank you to Mike as well, who's helped to verify some of the information for us. So on that note, I'll sum up, and I'm prepared to take questions and answers, and I'm sure the panel are as well. So over to you, Mick.